Hello, everyone. Welcome to practice set for lesson 36. We're talking about ratios and sample spaces. Let's get started. Uh, Whenever we have a ratio, what we're really just doing is comparing two numbers to each other. The comparison can be written in any number of ways, four specific ways, which, if you looked at the notes, you'll know what those are. So, in the pond were 240 little fish and 90 big fish. What is the ratio of big fish to little fish? The important thing to know when you're writing a ratio is that the order does matter. If the order is big to little, then that's the order we have to write the numbers in. So even though in the problem it gives us the little fish first, when we write the ratio, the big fish actually has to present first. So it would be 90 compared to 240. That is our ratio of big fish to little fish. Now, that's not the only way to write this. We could also write this as a fraction using the word 2 here. And we can also write it as a regular fraction, numerator denominator, or as a sideways fraction with the forward slash, I believe. Now, what we have to do is ask ourselves the question: do we simplify ratios? And the answer is yes, we do simplify them. So we have 90 compared to 240. We can eliminate the zeros. And then we have 9 to 24, which we can simplify by dividing each of these by 3, which gives us 3 compared to 8. The ratio is 3 to 8. And you read it as the number 2, the other number, as long as it's simplified. B, 14 of the 30 students in the class were girls. What was the boy-girl ratio in class? So we want to compare boys to girls. We know that 14 are the number of girls. So all we need to figure out is the number of boys. Now, the number of boys is given to us by subtracting, 30 and 14, which will give us 16. In this instance, it is inferred that, we have 14 girls and then the rest of them have to be boys because it's a boy-girl ratio. And again, just like if you had a regular fraction, if you can't simplify, you do simplify it. So 16 to 14, we divide both by 2, which gives us 8 to 7 for the ratio. C, the team won 3/8 of its games and it lost the rest. What was the win-loss ratio? So if it won 3 out of a total of 8 games, the number of wins is 3. And then we're going to use the word 2 here. So we got to figure out how many games it lost. Well, the team played 8 total games, lost 3 of them. So then we would subtract to find the amount of games that were lost, which is 5. For D, the bag contained red marbles and blue marbles. If the ratio of red to blue, so again, the order here matters. Red to blue was 5 to 3. What fraction of the marbles were blue? So in order to figure out our fraction, we want all the blue marbles, and then the denominator is going to be the total number of marbles. Now, in order for it to be a ratio, even if it's a simplified ratio, the total comes from the combination of both of the values that are being compared. In this instance, we're comparing red to blue, which would be 5 to 3. So the combination would give us a total of 8 marbles, and the blue marbles is the second value, which is 3. So the fraction is 3/8. What is the name for the list of all possible outcomes of a probability experiment? In a probability experiment, you have any number of outcomes. So many various different things can happen. But all of the possibilities combined give you something called the sample space or sample spaces. Sample space is basically a list of every single thing that could possibly happen in an experiment. So if I were to flip a coin, I could get heads or I could get tails. So my sample space would be H and T. If I were to pick a number between 1 and 20. My sample space is all the numbers 1 through 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that would be the sample space. The sample space is just a list of every single thing that could possibly happen. F, a penny and a nickel are tossed in the air once. One possible outcome is heads, tails. So H for head, T for tails. The penny is first and then the nickel. You want to list all the possible outcomes and then write down the sample space in braces. So how this works is you have to basically, it's kind of like a tree, right? So the penny could be heads, and then the nickel could be tails. Now, the penny could also be heads, but then the nickel could also be tails. So that right there is one different outcome, right? Now, the penny could be tails because we're flipping it first. And then the nickel could also be tails. And again, the penny could be tails, but then the nickel, given that it could be something else, is going to be heads. Now, the reason that we don't include the things with the nickel first is because in the problem, it lists the penny, then the nickel. If it was the other way around, you could say nickel could be tails, penny could be heads, but the nickel is never first in this instance. So then when we record our sample space, we put the braces, and then we just list, the combination of the probabilities. So in this instance, it would be HT. We HT, HH, TT, TH. And that is your recorded sample space for all the possible outcomes from flipping the penny and then flipping the nickel. So something similar for G, you toss a coin, and the coin could be heads or tails. And then you spin the spinner, which has 3 sections that are equal, of equal size. Use a tree diagram to find the sample space for this experiment. So in the tree diagram, you just kind of create roots from each of the first things that you're doing. So in this instance, if I flip heads, I could then spin 1, 2, or 3. If I flip tails, then I could land on 1, 2, and then 3. So our sample space would be all the possible outcomes: H1, H2, H3, T1, T2, T3. So we have a total of 6 outcomes that could possibly take place. Number H. With one toss of a coin and one spin of the spinner spun in problem G, what is the probability of getting tails and a number less than 3? So we have 6 total outcomes. So the probability is out of 6. And then we need to find all the total outcomes that fit our description. In this case, probability of getting tails. So first thing that has to happen is we land tails. And then we have to get a number less than 3, which is 1 and 2. So that's 2 total possible outcomes out of 6 total outcomes. And remember that with probability, you do want to simplify the fraction, which I will let you do on your own. For I, which sample space below is the better way to show the possible outcomes of rolling 2 numbered cubes? Now, which one is better? Why is it better? And then use it to find the probability of rolling a sum of 7. So the first one shows us all the possible numbers you could get when you roll them. But as we've gone over when we talk about multiplication, 3 times 5 isn't necessarily the same thing as 5 times 3. The order does matter. And when we talk about rolling number cubes, even though you end up with the same sum, like 3, you arrive at it at different ways. You could get 2, 1, or 1, 2. Those are different combinations. And as such, they need to be a different sample. In Vegas, when you're, playing at the dice table, I forget what it's called, they differentiate. They don't just say roll an 8. they'll say roll a hard 8 or a soft 8. And that's because there's a difference in how you get to the 8. A hard 8 is the most difficult one to get to, which in this case would be doubles, 4, 4. At least I think that's how it works. And then a soft 8 would be 3 plus 5 or 5 plus 3. So even though all three of those equal 8, they are all different samples, all different probabilities of happening. So they need to be their own probability and they need to be recorded as such. So sample space 2 is better to display the sample spaces than sample space 1. And to find the probability of rolling a sum of 7, we find out how many total probabilities you have in sample space 2, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6 is a total of 36. And then find all the 7s that are here, and that would be your numerator. Let me know if you have any questions about the practice set in the comments. Hope you have a great day.